Hi, my name is Marcus O'Sullivan. Welcome to APEC 2016. I'm here today to demonstrate some ADI's hotswap controllers. I have a 12-volt hotswap controller, the ADM1278, and I have a plus 48-volt hotswap controller, the ADM1272. I'm going to focus the demonstration today on the ADM1272 since it's our most recent development. So to demonstrate this today, I have two power supplies, a 47 volt and a 56 volt. The 47 lower supply is connected in with a diode, and I'm basically going to switch from one supply to the other, switch in the higher supply, which will give me that line step on the input. And on the output, I'm going to observe that the output doesn't issue a reset and that the output voltage remains and the current remains flowing to the load. The ADM1272 also has a PMBUS power monitor, so we have telemetry on voltage, current, power, energy, temperature, and also fault statuses. So I'm going to demonstrate this on a live system with a 5 amp load. So here we have the two power supplies, 47 volts, 56 volts, connected in through a diode, and switches to control each one. Right now the 47 volt supply is turned on, so the hotswap controller is active. On the screen here we have the software which connects via the PMBUS to the controller, and it's reading back telemetry on the voltage, 47 volts, the output voltage 0 volts, the current is 0 amps. So I'm going to enable the controller. On the output side we have a 10 ohm resistor, and that's enabled with a MOSFET here through the power good signal. So when I switch on the load, it'll charge up the output capacitance, simulating the insertion, and then when the power good becomes active, it will enable that 10 amp load. So when I switch this on, I'm going to see the current here jump up to 5 amps approximately, and the voltage on the output also jump up to 46.9 volts here, so 4.9 amps. So that's reading back to telemetry here. So on the power supply here, I can see that the 47 volt supply is supplying the 4.5 amps. When I turn the switch, it's going to switch in the higher voltage supply, the 56 volts. I'm going to do that right now. So I've confirmed on the power supply that the current is now 5.5 amps on this power supply and 0 on the 47. And you can see here the input voltage transitioned up, the output voltage transitioned up, and the current bumped a little bit because of the higher voltage. But the system didn't issue a reset. The power good signal is still active, the output is still active. So the system managed that event by controlling the MOSFET in an appropriate way and protecting the SOA, and did not suffer any kind of reset due to that voltage transient on the input. I'm going to step back to the lower voltage supply again, and one more test I'm going to use to highlight the protection on this system. So it's also an overcurrent protection. So I've taken a screwdriver and I'm going to short the output of this 46 volt system, and we're going to see the hotswap controller shut down, issue a fault, and protect everything from this supply. And then I'm going to restart it to prove that there's no damage and everything's working. So here's the short circuit. There was a spark. The fault LED has come on. Output voltage has gone to ground. The current has gone to 0. If I check the faults, I see I have an overcurrent fault here on the PMBUS fault map, and that the hotswap's off, and it indicates that it was a severe overcurrent due to the short circuit. If I go back to the main screen, I have the fault removed. I can power cycle the device, and the output comes back up and everything's functioning as normal. So thank you for watching. Please go to www.analog.com to check out our various range of hotswap controllers from 12 volts, minus 48 volts, and now plus 48 volt devices. Thank you.